Okay. The first question I want to go over is this one, number 7 of the Math Excel assignment. You're going to see a couple like this on Friday. So the first part of this asks you to take this point M and rotate it around point P by 90 degrees counterclockwise. The first thing I think we need to do is, one, make sure we turn around, pay attention. And the second one is to decide what our rule is.
I got 100 on that.
So if I'm going 90 degrees around the origin, and the point is A comma B, it turns into negative B comma A, right? That's our rule. Okay? Can you turn around?
Yeah.
Okay, turn around and maybe we'll close the window. Okay? You'll be okay. You're a tough guy. It's hot in here. Huh? Where's your sweatshirt at? No. Alright, so 90 degrees. 90 degrees around the origin. Okay? Is this rule. Yesterday we walked through a process that said we need to, in order to apply that rule, we need to actually rotate around an origin, right? Well, P is not an origin. P is 4 units to the right and 2 units up from the actual origin, right? So yesterday we went ahead and said, okay, well, let's make that 0, 0, and then rename this off of that 0, 0, right? And we end up calling that 6, 3 if we were to count over and up, right? Does that make sense, everybody? Okay. Now, you could do it this way. You could say, well, if I want to rotate around the origin, let's take this entire picture and move every single part of it down 2 units, to the left 4 units. So basically what we're doing here is trying to get our center of rotation translated to the origin. Does that make sense? If I translate to the origin, now I'm going to move this down 2 units, and this left 4 units, so it would go right there. Does that make sense? Now if I go back to the true origin and figure out what that point right there would be, it would be 6, 3. Then we said, well, let's rotate that. Let's use this rule. So flip-flop them and negate the 3, so it would be negative 3, 6. So now 1, 2, 3, 1, 2, 3, 4, 5, 6. So the point would go right there. Does that make sense, everybody? And we talked then, if I connect that with that, 90-degree angle, right? So it shows that we have rotated 90 degrees. But now, remember, what I just did was I rotated around that origin right there, correct? I need to take that point P and move it back 4 units to the right and 2 units up. Don't I need to take this point, move it 4 units to the right and 2 units up? So what should I do with this one? 4 units to the right, 2 units up. And when we do that and come back and count, that point's going to be 1, 8. Is that all right? Okay. So I want to kind of keep that idea in mind. I want to go through this process. We took yesterday, we started with the point that we wanted to rotate. We want to rotate 10, 5. So we start with that point. And I told you you're going to subtract away your center of rotation. You're going to subtract away 4 and subtract away 2 from the respective x's and y's, right? What that process is doing is taking this point here and it's moving it there to the origin. It's taking this point here and moving it there to 6, 3. Does that make sense, everybody? So that's going to give me the ordered pair 6, 3. You then take your 6, 3, put it through your rule, and it becomes negative 3, 6. And that produces this point over here of negative 3, 6. Is that all right? The last step we did was that we take our negative 3, 6, and we're going to add back in our center of rotation. So we add back in a 4, and we add back in a 2, and that's going to effectively move this back to the right 4 units and up 2 units. And what do we get when we do this algebra? What's negative 3 plus 4? 1. Okay. 1, and then 6 plus 2, 8. Is that exactly what we got when we looked at the picture technique? Okay. So my hopes are that we can correlate, we can realize when we're doing the algebra, when we're subtracting out, that's moving, it's translating our rotated point, or a point that we want to rotate, in our center of origin, or center of rotation, to the origin. Then we can use our rule. Then when we add back in, it's moving everything back over to its starting point. Okay, that we start the question with. Does that make sense? Okay, and if you can do that, you should be able to effectively and efficiently come up with as many of these points that you need rotated around anything that you want very quickly. Okay, so the second one here says you're going to rotate the same point around P 180 degrees. Okay, well, if I'm 180 degrees and it's A comma B, what's that going to turn into? I agree with the negative parts. Negative A, negative B. Okay. Now, first thing, adjust everything so this point is listed off the origin. So we're going to take our 10, subtract out our center of rotation. Take your 5, subtract out your center of rotation. That's going to give you 6, 3 again, obviously, right? I'm now going to take 6, 3, and I'll put it through my rule, and it becomes negative 6, negative 3, right? I'm now going to take that negative 6, negative 3, and I'm going to add back in what? 4 and 2. And when I do that, I get negative 2, negative 1, and that then is that final image. And guys, when you graph this then, negative 2, negative 1, negative 2, negative 1, does that point look like it has been rotated around P 180 degrees? Yeah, it looks like it's half a circle, right? Okay. So that's the idea. That's the logic behind that process. The next one asks us something that is counter to our rules. Okay. Our rules say that a rotation 90 degrees around the origin, A comma B, turns into negative BA. 270 around the origin of A comma B turns into negative A, negative B. Oh, sorry, that's 180. Sorry. 270, that one around the origin, A comma B turns into B comma negative A. Okay? These are all counterclockwise, right? Okay? So that list, somewhere I hope you have listed that is counterclockwise movements. This one is saying clockwise. If you have a point anywhere in the coordinate plane, and I'm just going to put it right there, and I want to move it clockwise 90 degrees. Clockwise 90 degrees would go right there, right? Okay. How can I move counterclockwise to get to the same spot? 270. So when they say they want me to go 90 degrees clockwise, I'm never going to do that. I'm going to convert it to 270 counterclockwise. So 90 degrees clockwise, 90 degrees clockwise is the exact same result as 270 counterclockwise. Is that okay? So now what if I wanted to go 270 clockwise? What's that going to be the same as? Yeah, so this is going to be, so if they ever give me 270 clockwise, I'm going to convert that to 90 counterclockwise and run through that rule. Okay? So in this question here, when we go 90 degrees clockwise, I have to decide that I'm actually using the 270 rule, right, of going counterclockwise. So let's just start with the ordered pair that they give us. They start with A being at 2, 1. So the first step is to take 2, 1, and you're going to subtract out your center of rotation, right? So subtract out 4. Now just be careful here. I'm going to subtract out negative 2. So what's that going to turn into? -2, 3. Step 2 is to take that and run it through your rule. Well, our rule we just said was going to be this one here. So I'm going to flip-flop them. And now I'm going to make the y value negative. Well, it's already negative, so negating a negative turns into a positive. Okay, now the last part says take that 3, 2, and you're going to add back in your center of rotation. Well, that means I'm going to add back in the 4 and add back in the -2. Does that make sense to everybody? So when the first step, those subtraction signs are static. They're always minus. In the last step, they're always plus. And somebody earlier today said, well, if I know that my center of rotation was negative and I'm adding that back in, can I just write 2 minus 2? Yeah, you can. But I think keeping that straight in your mind of whether when you're adding or subtracting based on signs is dangerous. You're going to mess it up. Okay? But if I always know that this is going to be a plus sign here, and then a plus sign here, and whatever the signs are then for the 4 and the -2, put those in, and now this obviously tells me I have to do what operation? Tells me 2 plus -2 is actually subtraction, right? Okay. So that gives me the 0.70. If I go to 70, 1, 2, 3, 4, 5, 6, 7, it's right there. Does it look like there is a 90-degree angle between those two?
Mm-hmm.
So if I would have moved 90 degrees clockwise, it looks like that. Does this then end up being, if I go counterclockwise, is that 270? Yeah. Okay. So negative, or not negative, 70, positive 70 is my ordered pair for A. Okay. The second part of this question is structured off getting that correct. If I get that wrong, I'm going to get the second part wrong. Okay? So we call this A prime. The second part says, take A prime and reflect it across the vertical line that passes through P. How long is that distance, or how big is that distance there? 3. You take that 7 and that 4 and subtract and get that distance, right? Subtract that distance one more time from 4, and it should give you, so 4 minus 3 gives me 1, and that's going to give me then the x value for that point, A double prime. Does that make sense to everybody? So that was question number 2. What is A double prime? A double prime is located at 1, 0 after a reflection. Okay? The next question says something like this. I think I put a plus sign here for you, a box, a Y plus, and a box, right? And the question is, what translation do you need to use to take this blue dot and move it to the right and up so that it lands on top of A? Yeah. Add 1 to the X, add 1 to the Y. Okay? Now, the reason I give questions like this, you're going to start seeing more and more questions like this as we progress through the next 5 or 6 weeks that tier themselves like this, because the intercourse exam is going to do that. And they're not going to do it on every question, but there'll be a handful of questions that say, here are 3 parts. And part 2 and part 3 are predicated off you getting part A right, okay, or part 1 right. Math Excel, sometimes the questions that Math Excel creates, you can type in like part A wrong and go through all the similar exercises, and eventually it'll tell you what part A is, and then you can use that to find part B, right? So it might be a 3-part question, and you get 2 out of 3 on it, but you got the first part wrong. Okay? On the intercourse exam, if it's a 3-part question, you get the first part wrong, you're getting all 3 wrong. Okay? So I want us to make sure that we kind of get used to that, and we understand that. Okay? Let's open up that worksheet. Okay? So here's the idea, guys, and this is why I show you the algebra. I don't want you to draw a picture every single time you do one of these, because think about this. We're rotating just a singular point, right? But the idea is if you can do 1 point, you can do 2. If you can do 2, you can do 3. If you can do 3, you've just rotated A, triangle? 3 points?
Oh.
So if I can rotate 3 points, I can develop a figure. I can rotate now a polygon. If I can do 3, I might as well be able to do 4, and I can rotate a quadrilateral, right? Well, what if I give you 8 points, and I ask you rotate this octagon? Do you want to have to draw 8 of those pictures? No, you don't even want to draw 1 picture of an octagon, okay, in the coordinate plane. It's a pain in the butt. But if I know the 8 points, the 8 vertices of that octagon, the hopes are that we can take those 8 points, and we can quickly, from those 8 points, subtract the center of rotation from each one of them. Then run each one of those through a rule. And then take each one of those 8 new points and add back in our center of rotation. Does that make sense? So we should be able to do it systematically, very quickly. Okay? So what I mean by that, and this is kind of the process that hopefully you go through, and then we'll do it maybe on number 2 here, but let's just look at number 1 first. So we went through the rule that says we are going to take, step 1 is to take the point you're going to rotate, 3, 4, and you're going to remove from that the center of rotation, right? So -2, minus -2, and that's going to turn into the ordered pair 1, 6, right? You're then going to take step 2, you're going to take 1, 6, and you're going to run it through your counterclockwise of 90-degree rotation. So that was that rule. Hopefully we've done this enough. Is that, right? So this 1, 6 is going to turn into -6, 1. And now the third step is to take that -6, 1 and add back in your center of rotation. So add in the 2, add in the -2. So when I do that, -6 plus 2 is -4. 1 plus -2 is -1. So there we've rotated that 1 point effectively. It was more efficient than drawing the picture, right? Now, let's talk, and I'm going to give you one here that was not in the assignment. So let's say that I want to take B of -5, -2, and let's say C of 3, 7, and let's say D of 2, 1. And I want to rotate those 3 around this same point. Well, think about how you could do this. Maybe first write our rule down here. 70 degrees counterclockwise is going to be that rule, right? Okay. Are you going to take, so if I'm doing B, you're going to go -5 minus your center of rotation, comma, -2 minus your center of rotation, right? Does that make sense? So this is working with B. If I'm working with C, isn't it 3 minus the center of rotation, 7 minus the center of rotation? Do you see how the center of rotation stuff is the same? And then D would be 2 minus the center of rotation, comma, 1 minus my center of rotation. Do you see how you can do that kind of all systematically? And now I'm going to evaluate those. So that gives me, what, -8, -4. This is going to give me 0, 5. This is going to give me -1, -1. Now I'm going to run those through my rule. Run each one of them through my rule. So flip each one of them. Gives me -4, -8, and then negate the last one. Negate the y. Flip. 5, 0. Negating 0 is just going to give me 0, right? And when I flip these, it's going to be +1 there. Is that okay with everybody? Now you're going to add back in. You take -4 plus 3, comma, 8 plus 2. Here you're going to take 5 plus 3, 0 plus 2. Here you're going to take -1 plus 3, 1 plus 2. And now B prime, this one here would be -1, 10. So hopefully for your answer, you got -1, 10, right? If I was rotating this triangle, C prime would rotate to 8, 2, and D prime would rotate to 2, 3. And now I've rotated a triangle so much faster than drawing the picture, right? That makes sense? Now, I don't know if my structure there is great for you, my organization. Maybe you want to create a better table so that you know what all those ordered pairs are referencing. Maybe have headings on your table or whatever. But that process should allow you to move a large amount of points very quickly, okay? Or much more quickly than drawing the picture. Cool with that? All right. Have you guys ever had any experience with Microsoft Excel? Okay. So I'm going to show you here Microsoft Excel. What Microsoft Excel a lot of people use, or Google Sheets, whatever version you want to use, there's a lot of compatibility between the two. They are different. They have some different functions, some different ways of doing things, but there's a lot of compatibility between Google Sheets and Microsoft Excel. The number one way people mess around with Excel, I think, that aren't versed in it, is that they just use the structure. They come up with all the data somewhere else, and then they just go in and they type it in, right? So that's what I've kind of done here. I've typed that stuff in, okay? But what Google Sheets and Excel are better designed for is to say, okay, I'm not going to do the calculations on the side with my calculator. I'm going to say that this class has 120 points, okay? And these students receive that amount of points on that 120. Does that make sense? So what Excel and Google Sheets allows us to do is to take this number here, okay? So whatever's in that cell, okay? So right here it's 99.6. And I can then divide that by that cell. And now I got to put, there's some syntax here that we have to be knowledgeable about to get this to do this correctly. But that gives me the 0.83 instead of me having to do it on the side, right? Okay? Instead of me having to take now 57.6 and divide it by 120 to get 0.48 and the 25.2 divided by 120 to get 0.21, what I can do is just drag that down and it calculates those things for me instantaneously. Does that make sense? And what's awesome, let's say this student E, let's say they did some bonus work and they got 18 more points. Can I change that to 120? And does it change that amount right away? Let's say I messed up grading this person and they only got 30 instead of and we could change that score appropriately. Does that make sense? So Excel is meant so that things can change dynamically. It's not static. It's not you typed it in and it's going to be that way forever. Okay? We should be able to change other values, and that impacts other values other places. Okay? So, knowing a little bit about Excel maybe can help you develop a little bit of a program to create these ordered pairs that we're looking for on this assignment. Okay? What I've done here in those blue cells, just kind of work through here. And the reason I'm showing you this is I just want to give you these answers. Since we've seen enough examples, I think, of how to go through this. If you didn't get these answers for your homework, my hopes are that now we've seen enough examples, we've gone through enough practice problems, you can go back through maybe the last 3 or 4 of this handout and do them again tonight and guarantee whether you've done it right or wrong with the answers being provided. So what this is doing, these blue boxes, you should type in right here, or the way I set it up, that's just the ordered pair of the point that you want to rotate. This one here, okay, you see the subscript CR, that's my center of rotation. Okay? Right here, look what it's doing. It's taking P minus, it should say CR there, but it's taking the X value of the point you want to rotate, removing from the center of rotation. So that's that first step we go through, right? If I were to click on this, it says it's actually taking cell B2 minus D2. So whatever I put into B2, and right now it's a 12, and whatever I put into D2 is a 4, it's going to do that math. It's going to give me 8, right? If I change those numbers, you see how it changes that difference, right? 2 minus 4 is now negative 2, right? Well, in this cell here, we are taking C2 minus E2. C2 minus E2, that's subtracting the y's of your point you want to rotate and subtracting out the center of rotation y height. So that's what we want, right? So this point right here, negative 210, is the adjustment, the translation of getting something so you can rotate it around the origin, so you can apply your rules. Okay? The next two cells, all I do is if this is a 90-degree rotation, which is this first line here, if that's A comma B, all I've done is made this negative B comma A. So negative B would be that cell, that'd be that 10, right? So if I double click on this, it's showing you that it's equal to the negative of G2. Well, G2 was 10. If I negate that, I should get negative 2 in that cell. Or negative 10 in that cell. So I got that. Okay? This is representing the A value. Well, the A value doesn't get negated, right? The A value is just that negative 2 over here. So I'm asking to recall that. And then this stuff over here, what that is that's adding back in then from the negative 10. So that was the point that we have rotated. It's going to now add back in my center of rotation, which is at D2. And I should then get negative 6, 1. So if I look at this, I think this is question, so this is 2, okay, so make this 12, 13, and 4, 3. So this is the point we want to rotate. This is what we're rotating around, okay? And our answers then should look like, let's see here. This is the last question, so it says degree 270 clockwise. These are all counterclockwise. So 270 clockwise is the same thing as what counterclockwise? 90. So did you guys get negative 6 comma 11 for the last question? Okay, so negative 611 is the last question. Write that down. If you didn't get that, write that down now. And now we've seen enough examples. Hopefully you can go back through again tonight and generate that negative 611 the right way. Okay? Number 4 here would be 11. Negative 13. And we'll rotate around. I want to rotate around negative 5, negative 4. And it says I want to rotate 90 degrees clockwise. If I want to go 90 degrees clockwise, that's the same thing as what counterclockwise? 270. Did you guys get negative 14, negative 20 for the fourth one? Okay. And then the third one, we're looking at negative 4, negative 7, rotated around negative 1, 3, okay? And we're doing 180 degrees. Did you guys get 213 for the third one? 213 for the third one, okay? Not getting a lot of responses from you. Last couple classes, I get a lot of yeses, actually most people were getting these right. My hopes are, even though only about 1 or 2, 3, 4 of us have this stuff out, we can go through and do these processes, okay? Questions on this? We're good?
Yeah.
All right. Now I'm not asking you to use Excel, okay? But my hopes are that you realize that that's how a lot of the things that you work with. Like when we go to GeoGebra, and I click, I want to take maybe this point, A prime, and rotate it around P, and I type in this to be like 180, and it spits back an answer to me. What's going on in the background in the coding of this program is exactly what I did in Excel. Okay, somewhere it's taking the input values from the user, which were what I use, A prime, so it's taking my input of negative 4, negative 1. Okay, it's then saying, okay, if that person puts in negative 4, negative 1, now they're going to type in the degree that they want to rotate. Okay, and they're going to push on the button or push on the point that they want to rotate around. So I have defined for them the point I want to rotate, the center of rotation. So in the background, it grabs those things and subtracts them in the right order that we want them to be done. And then it says, okay, now apply, they said 180 degrees. Let's apply the rule of 180 degrees and then generate the outcome, which in this case would have been 8, -3. And then there's coding that says, okay, now how do we get that displayed for them in the graph? Okay? So an Excel sheet is a programming, so people that use Excel the right way use it to program, to make software that allows the organization and the adjustment of data to be done a lot more effectively and a lot quicker. Okay? I want to talk briefly about rotations today. Or not, dilations. Dilation. I already talked about rotation. What? So dilation. All right, so a dilation. Everything we've done so far with rotations and translations and reflections has been what we call an isometry, meaning that the pre-image and the image are ultimately congruent shapes. When we do a dilation, we don't get congruent shapes anymore. Okay? You read that, it starts talking about scale factor. What was the other aspect of this class that we talked about scale factors with? Similar shapes. Okay? So when we dilate, we're getting similar shapes instead of congruent shapes. Okay? The word dilation, okay, encompasses the two ideas. It encompasses the idea of either enlarging or encompasses the idea of reducing. Okay, this is 9.4, I think. When you want to enlarge something, you're going to apply a scale factor that's bigger than 1. If you want to reduce something, you're going to apply a scale factor that is between 0 and 1. Okay? Ultimately, what happens when we enlarge something, we multiply. Okay? When we reduce something, we're actually dividing, which that's why between 0 and 1, if I multiply by 1/2, isn't that the same thing as dividing by 2? Okay? So we try to stay with multiplication, but we can use division, but when we divide, we just got to realize, well, that's the same thing as multiplying by a number between 0 and 1. This is a really easy process, and if you understood how we rotate around points that are not the origins, when we get to questions tomorrow, the process for dilating around a point that is not the origin is exactly the same as rotating a point around a center of rotation that's not the origin. Okay, so what we've talked about in the last couple days is going to kind of cross over into tomorrow's stuff. Okay, but the base dilation process says if you want to enlarge or reduce something in respect to the origin, all you have to do is take your ordered pairs and multiply them by your scale factor. Okay? That's all you have to do. So I'm going to give you an example here. Huh? I wouldn't have to go back if I didn't have to wait for you to get your workout. Yeah, so if they give you an order pair of 2, 3 and a scale factor of 4, all you do is take the 2, multiply by 4, you get 8. Take the 3, multiply by 4, you get 12. 8, 12 is now that new dilated point. And if I do it, so our goal is obviously to dilate images other than just points. Okay, so maybe we want to dilate a segment or dilate a triangle or a quadrilateral, something like that. So we go around and do it to all vertices. But yeah, if you can do it with 1 point, if you can multiply your order pair by any number that they give you, you should be able to come up with a dilation. It's only with 0, 0. Tomorrow we talk about dilating around a different point, or with respect to a different point of dilation. We will put in kind of those 3 steps. We'll have to subtract out the center of dilation, then dilate, and then add back in the center of dilation. I don't know. I just show up and they tell me to either stay or go. All right, so the notation that they're going to use for this is they're going to use a capital D for dilation. The subscript they use will be a number for the scale factor. And then in parentheses, they will tell you the shape that they want you to dilate. So in this case, I'm just going to call this triangle ABC. So A right now, let's say A is at 2, 3. B is at 1, -1. C is at -3, 1. I'm positive. Now, if I'm going to dilate that, where is A prime going to go? If my scale factor is 3, we're going to take those two numbers and multiply them by 3. So where does it go? What's 2 times 3? 6. Okay. What's 3 times 3? 9. So A prime goes to 6, 9. Where's B going to go? 3, -3. So that's B prime. Tablet died, hold on. All right, so 3 to the right, 3 down. So there's B prime. 3, -3. Where is C prime going to show up? -9, 3. All right, so is that shape, is it the same shape? Yes, it's a triangle, right? Is it enlarged, though? Yes, okay. Now, what is nice about this is kind of interesting. If you, and we'll talk a little bit more about this tomorrow, if you were to take a line from A prime back through your center of dilation, which is the origin here, it's going to pass through A. If you take a line through B prime back to your origin, it's going to pass through B. If you go from C prime back to your origin, it's going to pass through C. Okay, so C and C prime in your dilation point are collinear. A prime and your dilation point are collinear. Same thing with B prime and your dilation point. Now what they'll ask you to do is, can you verify? Can you in an alternative manner guarantee or prove that what we just came up with is a fact, that these two things are a multiple of 3 of one another? Okay, so let's do this. Let's take let's go. Let's find, so I did A, B earlier. Let's go A to C. Let's find distance AC. You guys remember how to find distances with the distance formula?
Yes.
Okay, so distance AC is going to say subtract your x's. So it's 2 minus -3. 5. Square that, you get 25, right? Okay. What's 3 minus 1? 2, square that, you get 4. So AC's length is root 29, right? Okay. That's prime, so that's nice. Let's find A prime, C prime's length. Okay, so 6 minus -9 is 15. Square that. 225. Add to that with 9 minus 3. 6. Square that. 36. So that's going to give me root 261. Okay? Now, if I look at AC as radical 29 and A prime C prime as radical 261, it's not real obvious that those are multiples of 3 of one another. But if you simplify root 261, okay, you get 261 divided by 29 is 9. What's radical 9 the same as, though? 3. Is that pretty easy to see that they do have a factor of 3 in them? Okay? So that proves to us that multiplying just the ordered pairs by 3 will generate then ultimately a distance or a segment that is 3 times as big. Okay? So that's usually maybe something that they'll ask you a little bit in your homework assignments eventually. Okay? We'll talk more about dilations tomorrow. What I want to do today or tonight for your homework is there's a PDF in your email. They're very simple dilations, very simple rotations. Okay? They're mainly around the origin. There's one dilation that is not about the origin. It's the first one on page number 2. You do not have to do it tonight. We'll do it tomorrow. Okay? We'll start there in class tomorrow. you might want to come with those answers.
Might.
Yeah.
Do we get tested?
I think it'd probably be beneficial for some of us to have maybe another homework assignment to go into progress with this 9 weeks.
I know, I got a D in there.